pen is 14.5 centimeters and my arm is 60 centimeters. Trial 1.
Yeah, you'll get like 2 point something. Divided by 4.
Trial 2.
Yeah, they're common factor. Common factor.
Do it by part.
Yeah. You'll get
Trial 3.
Mas walang mukha mo, parang walang aking.
Okay,
Pangit
go.
kasi.
Let's solve it! Yes, dog, no.
Oo!
Yes.
Ang prahig
Let's go to your side.
Iiyak.
I'm just leaving you on.
Trial 5.
This becomes 59.
Over 78. What x equals?
You wanna
Something
out of it?
6.5.
Okay guys, just an error here. So what Ben said is his arm length is 60 cm and the pen that he used is 14.5 cm, and the procedure we use, the method, will kinda look like this. Okay, so then what we're trying to find here is the unknown height of the tall object. So what we did first is did 5 trials and counted the paces that Ben did. So trial 1 he made 7 paces, trial 2 also 7, trial 3 again 7, trial 4 6.5, and trial 5 is again 6.5. The equation to get the height of a tall object is this over the length of the pen is equal to the distance from point A to point to object, point A being Ben and the object being the door, and the arm's length from Ben, which is 60 meters. So when we replace these words with numbers, it's gonna be like this, and variables. Since we don't know the height of the tall object, we're just gonna make it a variable first to make it easy and general. X length of the pen, we're gonna make it 14.5 cm. The distance from Ben to the door is originally 9 meters, but since we're using centimeters, let's convert that to 900 cm, and the arm's length from pen is 60 cm. If you count all of these, like cross multiply 60 and x, which will become 60x is equal to cross multiply 14.5 and 900, and then 14.5 times 900 over 60 equals x, which is 217.5 cm, or the height of the door. Similar triangles can be evident in this method, and we can see this through this illustration in front. We can infer that the person looking at the pen is or can be forming a small triangle right there, and because the object is big and the vision of the person changes when he goes farther, just to make the pen look more like the size of the object, there goes the bigger triangle. And we can see that if we cut the small triangle and the big triangle and put them in different triangles, they're gonna be similar triangles. That's why similar triangles are evident in this method.
Okay, good morning. Today I'll be teaching you how to measure the width of a river that you can't cross. The first step is to find the landmark. So for today we'll be using that tree, that plant beside the metal pole as our landmark. That will be known as point A. Now we have to stand right across it, directly straight, and we have to mark wherever you stand as point B. next step is to turn 90 degrees and walk a certain number of paces. So I'll be using 5 paces. So 1, 2, 3, 4, 5. So this is for the 5 paces. So I'm gonna mark this down. And this notebook will be point C. So since I walked 5 paces from point B to point C, I have to walk another 5 paces, and then the 5th pace over there will be known as point A prime. So let's begin walking. 1, 2, 3, 4, 5. So now I'm going to mark this point, and this point will be known as point A prime. Now for the last and final step, what we have to do is walk a certain distance until point A and point C will be aligned. So let's start walking. 1, 2, 3, 4, 5. So from this point over here, you can see that the point C aligns with point A. So I'll be marking this as point B prime. Now, since we know that line AB corresponds to line A prime B prime, the distance of line A prime B prime would be congruent to the distance of line AB. So now I have to walk us back the certain number of paces to know and compute how long the width would be. So 1, 2, 3, 4, 5. Well, since that's 5 and my pace factor is 1.5, we multiply that to each other. So that's 5 times 1.5. That'll be equal to 7.5. So the distance of line AB is 7.5 because line A prime B prime is 7.5.
Good afternoon. I am Simon Salvador, and according to Arthur's method, he used the plant and named it point A, while the point he was standing on, he named it point B. He then turned 90 degrees and walked 4 paces and called it point C. He then walks an equivalent distance from point C to point A prime. He turns 90 degrees away from the pool and walks to the point wherein points C and A are aligned. He calls this point B prime. With the information given to us, we can now say that angles ACB is congruent to B prime C A prime. This is because they are vertical angles. We can therefore conclude that these two triangles are congruent due to the ASA postulate. We can now say that lines A prime and B prime is congruent to A and B. This is because of the CP-CTC, or congruent parts of congruent triangles are congruent. We can now measure the width of the river by measuring point A prime to B prime. This is because this is congruent to A and B.